Welcome to chapter 11, which is on vectors. So the chapter has some elements that will seem familiar from GCSE, such as what a vector is, adding, subtracting, multiplying by a scalar. But then we have some sort of different applications, okay? So talking about magnitude sort of being about using Pythagoras really, and direction of a vector, this could be related to things such as bearings and angle, sine rule, cosine rule, SOHCAHTOA, things like that. Position vectors versus coordinates, what a position vector actually is. And then probably the most challenging part is some of the geometric problems that we're going to face. Finally, we look at applying this in particular to mechanics, which is where it comes up quite a bit. So, some basics of vectors. Vectors are fundamentally different to coordinates. Coordinates tell you where something is. A vector tells you how to get there, okay? And it tells you how to get there by breaking it down into sort of horizontal and vertical components. And in fact, this extends to depth for 3D vectors at the end of year 2. It's got a direction, as you can see. I could make this a bearing, perhaps, for example. I could tell you the bearing of this vector. And it's also got a magnitude. Magnitude could be thought of as its length, perhaps the hypotenuse. We can talk about vectors being parallel to each other. Again, this is sort of something from GCSE. So a vector of 1, 2 would be parallel to a vector of 2, 4. Direction and negatives. Well, if we define AB, as you can see, given with that arrow, the movement from A to B as A, if we change the order and we talk about B to A, we talk about going backwards, then we need to use negative A, is how we would say this. So direction is important. And probably one of the underestimated elements for vectors is the idea of vector addition. So this is a bit like a dot to dot with letters. How do you get from A to C? Well, you might start at A and then go to B first of all, which would be like this. That's called vector with a little a. That's defined as little a. Then what movement would you have to do after that? Well, if you've just moved to B, you have to move from B. So you might move from B and then to C, which is where we wanted to end up. So here you don't see B, but A to C might be AB plus BC. Okay. If you know what these are and these are defined for you, then you can do something like this. Vector subtraction. So if you mix the last two steps together, if that direction is A and that direction is B, well, that direction there must be minus B. And we can sort of stack them on the end as long as we use addition. If you do A and you add on means sort of you follow on with minus B, you would be left with A minus B, which would be this blue vector here. I've seen an exam question come up for this that was very, very poorly answered because you needed to reverse B and talk about minus B and do something just like this. That's why this one is in yellow, because it's an important idea that causes quite a few misconceptions. A zero vector, well, a zero vector just means we're not going anywhere at all. It means there's no movement. And scalars, so we're talking here about parallel vectors. They might be in the same or they might be in the opposite direction, but they have the same ratio. This is very important. They have the same ratio of x movement to y movement. Okay, if you do the ratio x to y, x to y, x to y for all of these, it would be the same. And finally, we can perhaps sometimes represent this scalar. Often when it's unknown, we might call this lambda. And this sort of can just represent the idea that we have one vector that's parallel to another. For example, if you see there, you can multiply by 1.5 and by 1.5. You can write that one is equal to the other with this sort of factor here on the outside. When it's not known, we might use this symbol instead. Those are the vector basics. And I'm going to use a GCSE exam question just to sort of discuss some. So we have some defined movements here as A, B. We also have a parallelogram, and it's really important to remember that on a parallelogram, we have parallel sides. So if that's A, that's A. If that's B, that's B. Write down in terms of A and B an expression for SQ. So how do you get from S to Q using the predefined vectors? Well, if I go to SP, because I've got a letter there, and then I go from P to Q, that will do it. SP, it uses the B vector, but it goes backwards. So I'm going to say minus B. Then I add on which movement? Movement A. So something like this to get us started. For part B, express N to R in terms of A and B. So again, we use sort of breaking the instructions up part by part, how are we going to do this? So N to R, maybe a sensible way to do this would be to go from N to Q, and then Q to R, dot to dot with the letters. QR, I know what that one's going to be already. I can see that that's going to be B. NQ is less obvious. NQ is a fraction of the movement from S to Q, isn't it? If S to Q is a big movement here, this is 2 to 3 parts. So N to Q must be 2/5 of SQ. And often at GCSE, the way the questions work is that they make you work out something useful in part A for part B with vectors like this. So we know what SQ was from before, and we know that QR is just B. So all I would do is I would just take that result and put that in there and work it forward. Okay, so this is just sort of a recap, but vectors do come up quite a bit in A-level, so you should make sure you're comfortable with the basics first of all. Have a go at a very similar sort of idea with this question here on the board, so pause the video and have a go. So I'm going to assume that you've done that now. A to B, the best way to do this is AO plus OB. Compare OA, which is A, to AO. If you're going the other way, then you negate it. So minus A plus B. 3 and 1, you need to be using fractions, which will either be 3/4 or 1/4. And again, sort of using this idea of a substitution from the first part. So there are some questions on Solomon worksheet here to practice this idea, and some of the more interesting or more unique questions are taken here from the book.